So, hi guys. It's ACI 1, Analog Aircraft Instruments, and our Module 3 is about the pitot-static systems. So, alam naman natin, or some of you may know, that some of the most important flight instruments ay kinukuha yung mga indication from measuring air pressure. So, lahat ng pag-gather and pag-distribute ng various air pressures for flight instruments ay nanggagaling kay pitot-static system. So, sa mga simple aircraft, this may consist of a pitot-static system, head, or pitot tube. Kaya kung nakikita nyo dito sa may image na to, okay, ayan, yung example ng pitot-static tube. So, kinukuha dyan yung impact and static air pressure ports, and meron siyang mga leak-free tubing connecting this air pressure sa mga pick-up points to the instruments that require the air for their indication. So, kung napapansin nyo, nandyan si altimeter, air speed indicator. Okay. Altimeter, airspeed indicator, and si vertical speed indicator. Yan yung the most common na ginagamit ng mga pitot-static instruments. Now, kung titignan naman dito, pitot-static tube, kung nakikita nyo yung open, it's open face, yan, into the airstream. Yan, kung titignan nyo kung nasan yung ram air. Okay, so, please search kung ano ibig sabihin ng ram air. So, ulitin natin, yung open, yung opening ng pitot-static, which is nung pumapasok yung ram air, siya syempre naka-face dun sa may airstream to receive the full force of the impact air pressure as the aircraft moves forward. So, yung air passes through the baffled plate. Yung baffle plate designed to protect the system from moisture and entering the dirt. Okay, so parang lumalabas na filter si baffle plate. So, dun kay baffle plate, meron siyang drain hole. Okay, so check nyo si drain hole kung nasan. Siya yung nagpo-provide allowing moisture to escape. So, syempre, hindi naman pwede magkaroon ng moisture build-up dahil pag nagkaroon ng moisture diyan sa loob ng pitot-static, magiging ice yon or magyayelo and babara. So, hindi na siya makaka-measure ng air pressure. So, yung ram air is directed to the aft chamber in the shark's fin of the assembly. Yan, yung mukhang shark's fin, ha? Itong part. So, an upright tube or riser leads to this pressure air out. Ipito assemble to the airspeed indicator. Ito na yun. So, the aft section of the pitot tube is equipped with a small hole on the top, on the bottom, and bottom surface that are designed to collect air pressure that is at atmospheric pressure in a static or still condition. Ulitin natin yung aft section of the pitot-static tube is equipped with small holes on the top and bottom surface that are designed to collect the air pressure that is at atmospheric pressure in a static or still condition. So, yung static section also contains a riser tube and ito na yun, dito din yan. And is connected to the altimeter, the airspeed indicator, and the vertical speed indicator. So, halos lahat ng pitot-static meron siyang heating element from prevent syempre yung moisture build up during flight. So, yan yan. Meron niyang heating element. So, sa susunod, you may experience yung pitot-static tube if papunta kayo sa aviation industry. Pagkatapos ng flight, pag kinapitan nyo yan, mainit yan. So, yung pilot can send electric current to the element which switch the cockpit. Ayan. So, para matanggal yung mga ice forming condition na pwedeng mag-exist dun sa may pitot-static. So, the switch is wired through the ignition switch so that when the aircraft is shut down, a pitot tube heater inadvertently left at hindi siya mag-continue ng draw ng current sa battery. Okay? So, kasabay siya sa ignition system. Siyempre, baka hindi mapansin ng piloto. Example, kung nakahiwalay yan, hindi siya mapansin na nakabukas. So, masisira lang din or madidrain yung battery ng mismong aircraft. So, ulitin ko lang ulit, umiinit yan. Kaya, if magkaka-experience kayo sooner na sa aviation industry, huwag niyong kakapitan si static agad-agad. Okay, so put an extra caution. So, the pitot-static tube is mounted outside the aircraft. Okay. And at point where the air is least likely to be turbulent. So, hindi lang basta-basta din nilalagay si pitot-static. Dahil yun nga, siyempre kailangan niya yung sinabi natin dyan is kung saan siya medyo hindi turbulent. So, it is pointed forward direction parallel to the aircraft's of line of sight. Siyempre, hindi naman pwede yan nakatalikod dahil wala ka namang makukuhang hangin kung nakatalikod si pitot-static tube. So, siyempre, yung location pa din, pwedeng mag-vary sa mga ibang aircraft. Yung iba nakikita nyo sa nose ng fuselage. Yan, katulad nakikita nyo sa image and yung iba sa may wings. So, madami na rin design ang nag-exist. So, siyempre, same lang din naman sila ng pagkuha ng air pressure and static air pressure and mapupunta sila sa may mga instruments. So most of the aircraft with a pitot-static tube have an alternate source of static air pressure provided for emergency use. So yung pilot may select an alternate with a switch in the cockpit. Yan. So Pag mga low-flying, unpressurized aircraft, the alternate static source may be simply galing lang sa may cabin air pressure. Okay? Katulad nung sa mga Cessna. Okay? Kung nakikita nyo yung alternate static source cockpit, nakalagay lang yan sa may loob na cabin mismo. Okay? Doon lang sila kumukuha ng source ng air pressure. As an alternate, ha? Gamitin natin pag unpressurized. Okay. Now, pag mga pressurized aircraft, cabin air pressure may significantly different than the outside ambient air pressure. So, pag gumagamit sila ng alternate source sa mga static air, instrument indication will be grossly inaccurate. Kaya kailangan nila ng multiple static vent to pick up yung air pressure. So, lahat ay located sa outside ng aircraft and plumbed so the pilot can select which source directs air into the instruments. And nakadepende, syempre sila sa may electronic flight display. So the choice is made which source is used by the computer or the flight crew. So another type of pitot-static system provide for the location of the aircraft static source at separate position on the aircraft. Kaya kung titignan nyo dito sa may figure 26, meron silang heated primary and alternate static ports, static vents, sorry, located sa may mga side ng fuselage. Kung titignan nyo, yung mga static vents na yan is merong red na mark kasi yung nakalagay. Bawal siyang ma-deform or bawal siyang ma-plug or takpan dahil kailangan yan smooth and clean. So, itong mga pitot-static, ginagamit only for to gather the ram air pressure. So, separate static vents are used to collect the static air pressure information. So, there may be 2 or more vents na pwede nyo makita sa may aircraft. Meron siyang primary and alternate source. And as well, separated, syempre, dedicated vents for the pilots and the first officer. Kaya kung makikita nyo din dyan, meron siyang nakalagay na for captain and for first officer. Iba may nakalagay pa na standby. Syempre, pag wala, nasira yung dalawa, meron nga pang isa. So, yung mga, meron ding 2 primary vents may be located on opposite sides ng fuselage and connected with Y tubing. Okay, simply Y tubing. Example lang, ito yung isang tube, Y, meron dito sa kabila and meron dito. So, ginawa to compensate for any variation in static air pressure on the vents due to aircraft's attitude. So, syempre, umiinit din yan, heated as well as the separate ram air pitot tube to prevent icing. Yun yung laging purpose ni heater. Kaya minsan kung meron kayong makikitang mga walang pintura or not painted na part sa aircraft, most likely yun yung meron silang de-icing or merong heater para maiwasan yung ice buildup. Okay, syempre, Si pitot-static system are very complex sa mga multi-engine and pressurized aircraft. And additional instrument gauge, the autopilot system and computer may need a pitot and static air information. Yan. Kaya kung titignan niyo sa figure na 'to, schematic of a typical pitot-static system sa pressurized multi-engine aircraft. So, a pitot-static system para sa pressurized multi-engine aircraft with dual analog instrument panels in the cockpit. Ayan, ito na yung dual nun dito. Mapapansin niyo meron na siyang altimeter indicator, airspeed, and kasama din yung rate of climb indicator. So the additional set of flight instrument for co-pilots alters and complicates the pitot-static system plumbing. Okay, yung mga nakikita diyan mga yung plumbing, yung mga tubo-tubo. So the autopilot system requires static pressure information as does the cabin pressurization unit. Okay, so tignan niyo mabuti kung saan. So separate heated source for static air pressures are taken from both sides of the airframe to feed independent static air pressure manifolds. So one each for the pilot's flight instruments and co-pilot's flight instruments. So designed to ensure that there is always one set of flight instrument operable in case of malfunction. Yan, kung titignan nyo, pilot's instrument pitot tube and pilot's pitot tube. Nagdiretso na siya dito sa instruments. And yung iba naman, yan, meron pang mga unheated tube. So, need yung nila ng information for the autopilot. Meron silang autopilot static drain valve. Yung iba din, may mga drain valve. Nakikita nyo. Siyempre, para kita paano lumabas yung moisture buildup. And for some, ito, for cabin pressure control panel. Meron din sila dito to ensure na tama pa din yung nakukuha nilang atmospheric pressure. So now, we'll talk about a quick one for the air data computer or digital air data computer, ADC or DADC. So sa mga high performance and jet transport category, aircraft pitot-static system may be more complicated. So, syempre, these aircrafts frequently operable at high altitudes where the ambient temperature can exceed 50 degrees Fahrenheit below zero. So the compressibility of air is also altered at high speeds and at high altitude. So, kanina pinag-uusapan natin yung directly at diretso yung nakukuha nilang air pressure to the computer. But yun nga, yung compressibility ng air is na-alter at high speed and sa high altitudes. So, airflow around the fuselage changes and making it difficult to pick up a consistent static pressure. So, airflow around the fuselage changes nga daw. So, the pilot must compensate for all the factors ng air temperature and density to obtain accurate indication from the instruments. So, sa mga analog instruments have a compensating device at ginagamitan sila ng air data computer. So, si ADC is common for the purpose ng mga high-performance aircraft and yung mga conversion ng mga of sense air pressure into digital values makes them more easily manipulated by the computer to output accurate information that has compensated for many variables encountered. Sinabay ko lang to, syempre, baka sa susunod, maisipan nyo magtanong about this. So, ito pala, yan. Ito yung uh, itsura nung ADC na computer. So, siya yung nagko-compute ng air data information from the pitot-static pneumatic system aircraft temperature probe and barometric correction device to help create a clear indication of condition. So, naka-computer, in short. So, essentially, all pressures and temperatures captured by the sensors are fed into ADC. So, yung mga analog units utilize transducer to convert this to electrical values and manipulates them in various modules containing circuits designed to make the proper compensation for the use by different instruments and systems. So, yung mga the ADC usually receives its data in digital format. So, system that do not have digital sensors output will first convert inputs into digital signals via an analog to digital converter. So, merong mga numerous benefits paggamit ng ADC. Siyempre, unang-una doon yung simplification ng pitot-static plumbing lines. Create a lighter, simpler system with fewer connection. So, mas lesser siya sa prone to leaks and easier to maintain. Yan. So, katulad din nakikita nyo kanina, mas madaming tubing or plumbing. Now, kung titignan nyo dito sa ADC, diretso siya lahat from the digital air data computer and directly mapupunta into different instruments. Okay? Bukod sa mapupunta siya sa may mga pilot's altimeter, indicators, pwedeng air temperature gauge, mapupunta din siya sa pwede sa transponder, flight management computer, sa augmentation computer, autopilot system, flight recorder, flight director system. Tuloy natin from the PITO static pressure sensing flight instruments. The basic flight instruments are directly connected to the pitot-static system on many aircraft. So, analog flight instruments primarily use mechanical means to measure and indicate various light parameters. And yung digital light instrument systems, gumagamit sila ng electricity and electronics to do the same. So that's all for the module 3.